Hi, I'm Professor Justin Ren, and this is Top 10 Excel Skills for Successful Business Professionals. First of all, a warm welcome to the class. In this brief introduction, I will just talk to you about why should we learn Microsoft Excel well and what is covered in this class. Also, all the Excel files are downloadable at excelprof.com. Now, why do we want to learn Excel? According to this recent Wall Street Journal article, the percentage of mid-level jobs that require fluency in digital skills such as Microsoft Excel is astounding 78%. And moreover, those jobs that require digital skills such as Microsoft Excel pay about 13% more than those jobs that do not require Excel. Hopefully this two picture would convince you the importance of Microsoft Excel. Now, from my experience of teaching students and talking to employers, I compiled this list of top 10, and let me just quickly go through them. First of all, hotkeys are important, so you should be able to use, say, Control or Command Arrow key to quickly navigating a data set. And VLOOKUP is very important, and I hear this from employers again and again. You want to be able to find numbers quickly using index and match function. Use advanced if, such as COUNTIF and SUMIF. And SUMPRODUCT is very nice feature in Excel. If used properly, it can speed up your calculations so much. Working with text, say for example, parse text strings and concatenate. And also rank data, find the largest, the smallest, and find the percentile cutoff. PIVOTABLE is extremely important. It can give you lots of insights. Also in Excel modeling, using absolute and relative referencing with a dollar sign is essential. Lastly, in scenario analysis, which is part of the advanced data analysis, be able to use DATATABLE to conduct those what-if analysis very efficiently. I really look forward to your feedback. If you have a question, please let me know. Moreover, if you want me to cover any more topics, please also let me know. If you're happy with the course, of course, I look forward to your feedback. Also, I have more courses coming up. For example, a full course called Business with Excel, and also some specialty courses, things like simulation, optimization, and visualization, and much more coming. If you want to stay updated and receive Excel tips and tricks, sign up my newsletter. Thank you so much. This example illustrates how do you use Ctrl Arrow key combinations to quickly navigate within a large spreadsheet. Here I have a very long table that contains the history of NASDAQ Composite Index. You could use the scroll bar on the right of the screen to move towards the end and see that it has actually more than 10,000 records. But how do you quickly go to the end or basically the four corners of this table quickly without using any of those scroll bars? Well, there's a shortcut. It's a Control with your arrow key combination. Suppose I want to go to the end of the table. So what I do here is just press Control and downward arrow key. As you can see, it goes to the last record. Now let's go up, Control up, and we could also try Control right arrow key. And as you can see, as long as your table is continuous, it will actually go to the furthest end. In this example, we use VLOOKUP to merge two data tables using exact match. So here's the context. In a small company where there are just 6 employees, we have two data tables. One is their phone extension. So in column B is the name field, and column C are the numbers extensions. In another place, and I just put in column G and H, there's a table about their functional area. Now suppose we want to merge these two tables together. we cannot just copy this table and paste it to the first one, because if you look, the names of different order. Plus, this manual steps, this kind of steps are always discouraged because it is very error prone. So what do we do? Well, it turns out if you look VLOOKUP, it can do a terrific job in this. Let's see how it works. So let's just say I use the first record as an example. If we use this as a base, or we could actually start a new worksheet and just starting with a list of names, that'll be fine. But let me just show you how do we just use the names to grab all the information. So here I type VLOOKUP, VLOOKUP value. Here we want to look up the person named Tom. And where do we look up? We'll go to the other table. Okay, and I press F4 to absolutely reference it because I want to use it to letter formulas. And I want Excel to return contents in the second column, i.e. their function area, and that's 2. Now finally here, do we want to exact match or not? Here we do, because we do want to match person by person. Okay, so here I type false, meaning that we want an exact match. Alright, so let's press enter. So it finds Tom, goes to this sheet and finds Tom on the last row, return whatever that is in the second column of that row, so which is accounting. Right, let's double click and see if got it right. So Alan is active here, Elena finance, Liz accounting, and Judy sales. So this way, let me just type division, give it a new name. So so this way we were able to basically merge 2 databases into one using an exact match. In this example, we learned to use a very useful pair of functions called match and index. As an example, I have here the weekly stock price of Google. We could compute the week-over-week return for this stock, which is just the ratio, the price of this week over the price of last week, minus 100%, or just minus 1. We could double click to get that number. To double check though, we go to the end of this series and notice that the first one should be corrected. It does not have a return number, this being the first day, so we delete that. Okay, now we have the week over week return number. Now a natural question to ask is, what is the maximum weekly return? Is it 10% or is it 20%? We also want to know when that maximum return happened. So in order to do that, first of all, find out the maximum weekly return number. To do that, it's quite simple. We just use max function and select the whole series. I press Ctrl Shift down to select all the numbers and press return. Now we see that we do have their answer, which is close to 20% on week over week return. Now, when did that happen? We break it down into several steps. First of all, we want to find out in this column in what position is this number appearing. So in order to do that, we use match function. So we say match lookup value, which is this maximum number, and lookup array, which is where to want to find out this particular number. So again, we press Ctrl Shift down to select C4 to C418, that's the whole series. Now match type is an option because we want to find out, as the hint suggested here, an exact match. So we just want to press 0, enter. Now it tells you that in this long column, this number appeared in the 407th position. With that knowledge, we could use index. So we use index. Now, where is this date information along with the return? So we use keyboard select this big table from A4 to C419, and we want to find out in this big table the 407th row, and we want also the first column, which is the date information. Okay, so that's that. Well, except that this is not what we expected in the format of a date. So what do? You could do format. Try to do here. Format cell. Format into a date. It'll tell you that. Okay, so there you have it. So that maximum jump happened in August 18th of 2004. Or you could use a date function. It's a little bit tedious, so you need to first of all identify the year of the following number, the month of that number, and the day of that number. So we get the same answer. This example illustrates the usage of SUMIF. In this setting, there's a restaurant rating agency who is rating 10 restaurants. Each restaurant is evaluated on 3 criteria: food, service, and environment. They also indicate whether they want to be included in the final published rating or not. The weights for the 3 criteria are 40, 30, and 30% for each. First of all, let's compute the weighted score for each of the restaurants. Let's do this more efficiently, so we'll use Ctrl Enter with one formula. For each of the restaurant, we could use SUMPRODUCT because the weights are fixed and each of the scores are nicely laid out. So we just need to type the formula for one of them. So I'll say SUMPRODUCT, and the weights here, because they are fixed, I would also use absolute reference. And for the first one, I just select the first row and close the parenthesis, Control Enter. So that's the weighted score for each of the restaurants. Now, the criteria for the restaurants is if one restaurant is over 80%, we could give a star rating. So to do that, we could have used a COUNTIF. Let's say COUNTIF those scores, and the criteria would be quotes and end quote greater than 80, and we would have got 5. However, this does not take into consideration whether a restaurant wants to be included or not. So in order to take that into account, we need to use SUMIF. So here's how you use SUMIF. SUMIF has the following argument. First of all, still the array of scores, still the same criteria, but for those cells that satisfy this criteria, we are going to utilize this binary 0101 to sum those who like to be included. How many of them are over 80? Okay, so let's see that. So indeed, it shows that these are different, which means that SUMIF has correctly identified restaurants that are both over 80 and are willing to be included. Now let's look at a class of problem called integer program. In particular, we're going to look at binary decisions, i.e. those go or no-go type of decisions. Here's the problem. A consulting company has 10 potential projects to take on, each with its hours listed here. It has 2 teams to take on those projects. However, no project can be shared by the 2 teams. Each team has at most 100,000 hours available. Now, since the hours are already budgeted, the firm would like to take as many projects as possible. The hours needed for each of the objects is here. Now, how many projects can be taken at most by the 2 teams? So now, just looking at this inputs, it's very hard to tell how jointly the 2 teams how many projects can take on. So we're gonna let Excel solve for us. So we're gonna have 20 binary decision variables, the 10 for each team, and in each of the decisions you can only take on 0 or 1. 0 means this project is not taken by this team. So a 1 would means that a certain project is taken by the team. So the advantage of formulating this way is that if we sum up in the rows, we get whether this project is taken at all by a team. If it is 0, then none of the team take this project. But if it's a 1, that means that some team is taking it. Also notice we can control that it will be less than 2, meaning that no project can be taken on by both teams. And in terms of calculating the budgeted hours, it's very simple. We just use a sum product so that we could immediately get the total hours for any given allocation. So again, this is the advantage of using binary variable. It only adds up those projects hours that are being taken. So we basically say here it less than 100 and 100. Everything is in units of 1,000, and that's why it is 100 instead of 100,000. And what's our goal? Well, our goal is really just summing up all the binary variables, right? If we want them to be as many ones as possible, so we're going to maximize that binary variable. So here's the solver part. Let's explain a little bit in detail. We want to maximize the total projects taken, maximize by changing the 20 variables, but they are not any variable. In fact, they are what we call binary. So the way you enter that is to say select all of them and just choose here bin, meaning binary. Okay, and there's also a budget constraint. So our constraint B30 to C30 is less than 100. So that's the constraint. And we also say our B18 to D27, D18 to D27 here is less than or equal to 1, meaning that no project can be taken by 2 teams, so that this indicator variable will be 2, so that's not allowed. It is a positive, everything is positive, and we're going to use simplex linear programming to solve it. Let's do it. So it is setting up, and you will see that it will give some kind of iterations, and this just shows that integer programming is actually a little bit more time consuming to solve, so we need to be a little bit more patient. Okay, now we found a solution. In this example, we learn a few functions and tricks working with text. I'm going to enter a zip code here as a string of text. The way to do it is add an apostrophe in the front. So here's my zip code here. Now, we're going to go through a series of exercises. First of all, how do we take the first 3 digits of this text string? We could use left function, select the text and enter 3. There we have it, 017. How do we take the digits from the right? For example, take the last 2 digits. As you guessed it, there's a right function. So we take the last 2. How do we combine this 2 string together and get our 5-digit code back? We could simply use ampersand to connect this 2. There we have it. Okay. Now, how to convert those text into numbers? There is a standard method which is just called value. If you enter value of this string, as in B7, we have 1778. Notice that it is now right aligned, indicating that it's indeed numbers instead of text strings, which are normally left aligned. There's also a trick to convert those text to numbers. We could just multiply this text by 1 and we will get our number back. Okay, now how do we convert number to text? Here, as you guessed it, there's a text function. However, there's one thing to note. In addition to enter the value, you are required to enter the format of the text. Here, the default or the most generally used is just 0, quote unquote. So let's enter that. Now we got our text back from numbers. All right, now let's go through the last block of exercises. How do we add 0? We have learned to use ampersand, so that's exactly what we will do. So let's add 0 to the text string we just got, so that we will have a 5-digit code. Now we have it. The last 2 exercises deals with the search function. How do we find the first 1 in this zip code? We could use find function. Find what? We won't find a 1 in this string of text, and the default start from the leftmost, so I'll leave it. Now the return 2 means we find the first occurrence of 1 at the position 2. Okay. Now how about from the first 1 that we just found and take the next 3 characters? Okay. So this is a little bit hard, but it can be achieved by what we call mid function, standing for middle. So we first will take the text, the whole string of text, which is in B13. Where do we start? Well, we just figure out the first 1 appears in position number 2. So we just use B14. And how many do we want? How many characters? From there, we want 3. So from the first 1 and take the next 3, we should get 177. And that's indeed what we got. This example illustrates the usage of 2 statistical functions. One is quartile and the other is percentile. We have seen this data before. There we were asked to compute the rank information of each of the markets according to their demand. In this example, we also want to group those markets into 4 buckets, and the breakpoints are 25 percentile, 50 percentile, and 75 percentile. In other words, we need to find the quartile cutoffs for this set of demands. We could do that by use quartile. Quartile 0, being the 0 percentile, is actually the minimum number, and quartile 4 is actually the maximum number. So let's compute that. So quartile, I want to identify this is the array we are looking for. Now here the quart, meaning that we need to enter a number between 0 to 4. Now I could have entered 0 and get the minimum value, but I want to do in one formula. So how do we enter the 0 automatically? Since we have 0 and to 4 in this column F, we can use a write function to truncate and get the numbers here. So to do that, you just enter the write, and this is the text we want from the write, the first number. So in here I should get 0. So now it give me the minimum number, and with that I can actually just drag it down, and these are the cutoffs, okay, from the minimum number, the maximum value, to the 25 percentile, 50 percentile, also the median point, and the 75 percentile. A more general way of calculating cutoffs is to basically use the percentile number. There you have more freedom in specifying a particular percentile. Here, let me illustrate. You can say percentile. If we enter the array here, I also want absolute referencing them. And here I just enter 50%. I will get the median or the 50 percentile number, which is 49, identical to quartile 2 by definition. I could also be more flexible, percentile, get the 90% here. The 90% is 54. So that illustrates the usage of percentile. Pivot table is a very powerful tool for analytics in Excel. Let's use a simple example to illustrate how useful it is. I have here a bunch of data. Basically, they are about the sales for 2 items. One is called Azure and the other called Peach. And they are sold currently in 3 markets: Atlanta, Boston, and Chicago. And we have 3 months worth of data in January, February, and March. Now the questions are, what are the sales trends for the 2 products, and what can we say about the popularity of each in these 3 regions? Now just looking at the data, you can't really see much in terms of answering the question. But if you build a pivot table, it'll allow you to aggregate or slice the data the way you want in order to answer those questions. Now let's build our first pivot table. To do that, you simply go to Insert, Pivot Table, and Excel would guess from the sheet where is the data, and in here it guessed correctly. But if not, you can change that. And do you want the pivot table to be in a new worksheet or not? Here I say new worksheet. Okay, so click OK. Now here's what you see. Well, not much of empty pivot table, and here are the fields, and those are the fields on the right are for you to build. First of all, let's just try things. Since we are to understand the sales trends for these items, why don't we just drag month to, let's say, row table. Now you can see that now we have 3 months of columns here. Now I want to understand the sales. That's the ultimate goal. So I just drag sales to this window here, value. Now by default it tells me the summation of sales in each month. So you can see some data trends already. Now to drill down a little bit, how about by items? Because just look at the data, there's not much variation here. Let's look at items. Now where do we put item? How about we try column label, because it's empty here. Now you see what it does is basically put the items in each column, okay? And now something interesting is showing up here. Now if I could just basically do a visual conditional formatting, nothing fancy here, you can see that even though the sales of the two items are pretty stable over a month, actually for each product they are experiencing very different trends. For Azure it is displaying an increasing trend, and for Peach it's ever decreasing. So if you bundle these two together, you can look at aggregate, things seems to be pretty stable, but in fact they are not. So now we basically answer the first question. Okay, so what else can we do? We click in the table. Notice that we haven't answered the question about regions. Are there any systematic differences in terms of which market they're in? Okay, so at this point you could try to put in column or rows. Let's try which one would help us understand better. Okay, so well, probably we should get rid of the conditional formatting first. So we clear rule from select cells. Not just eyeballing the data, we see there's a little bit of trend here. Okay, for Atlanta, so there's another way of building this. In order for us to see Atlanta for the 3 months, why don't we build region? We switch the region and month. Okay, so I just switched, drag it. Now what you can see here are pretty interesting. Let's see Atlanta. For Azure it is ever increasing, and for Peach is decreasing. For Boston, Azure is selling better and better. For Peach it seems to be weakening. For Chicago the same trend applies, and for Peach the same decreasing trend applies. So this seems to suggest across all markets these two products are having the divergence in terms of sales trends. By doing this, it really allows us to do the deeper insights analysis that is not possible without PIVOTABLE. This example illustrates how do we use absolute reference and relative reference in formula building. I have example here. A retailer is selling 4 products, A, B, C, and D, with different prices, and there are 3 types of discounts available: 7%, 15%, and 30%. Now the seller wants to make up the table where he could quickly look up the final unit price, that is the one after discounting. Normally, if there's just one, we could just say in here, type unit price, which is C4, multiplied by 1 minus the discount, D3, and we would be done. However, if you want to move that formula to, for example, same price but 15% discount case, if you look at the formula, it actually is not correct. This is because D4 here should be C4. So Excel automatically changes the location if we are not careful with how we reference each cells. How do we fill up this table with just one single formula? Let's first of all undo that and think about the correct way of doing this. The insight comes from the following observation. No matter which formula we need to fill, the unit price should always be in column C. So the column index of unit prices should always be fixed. Similarly, the three types of discounts are in row 3, and their row indices should be fixed. So with that insight, we could do the following. Let's first of all select the whole table, and let's think about how do we fill the correct formula. So instead of C4, because I want to fix the column index, I would type $C4. So this would fix the column index for unit prices. And the next one, for the discount, instead of D3, I would say D$3. So notice what I have done here. First of all, for the prices, I'm fixing the prices to be always in column C. And for discounts, I'm fixing them always in row 3. Okay. So with that, now I press Ctrl Enter. This is indeed what we're looking for. To double check, you can move on, say for example to this one scenario here, and you can see the unit prices is correctly referenced, and so is the discount. This example was introduced earlier in the course. Basically, we use COUNTIF and SUMIF to calculate how many restaurants their scores are over a certain threshold. At that example earlier, our threshold was 80. Now, the question is, what if we change the cutoff and see how many restaurants are over the new cutoff? And to make it even better, what if we build multiple scenarios and let Excel automatically tell us how many of them are over each of those thresholds? Here I have just 5 scenarios. So what about we start from low, say over 70, and then gradually raise the bar, so all the way to 90. It'll be cool if we can let Excel fill those automatically for us, so we don't have to do manual changing this cutoff 5 times. Data table in Excel provides exactly that functionality. Let me show you how to do it. The first is the scenario building, and we build in the column. And secondly, you put your desired quantity up on top. Here, the model indicates that our B32, which is the count the number of restaurants that are over that threshold, is in cell B22. So here we enter B32. We enter B32, and somehow it's not done. Let's do it again. And then we select everything, include that header, and go to Data, What If Analysis, and under What If Analysis, Data Table. Now this is a one-way data table, so we don't need to put in anything here because everything, the 5 scenarios are in columns, so we need to fill in column input cell. Now this is asking you, those numbers, what are they? Well, in the original model, they are basically the cutoff. So we need to say, well, these columns are basically the cutoff, which is in B4. After you do that, click OK, and Excel would automatically compute that for you. In this example, we discussed the usage of net present value calculation in Excel. I have here a simple example. Suppose Tom is interested in investing in real estate. This apartment costs $425,000 as an initial investment, and after he buys it, at the end of each year, he expects cash inflow to be $30,000 per year, and he expects to hold this apartment for 7 years, and at the end of 8th year he's supposed to sell it, and the selling price to be $470,000. Now the central question is, what is the net present value of this whole investment? Before we talk about the NPV function itself, there are a couple of things to keep in mind. First of all, this NPV function assumes the cash flows happens at regular intervals. So if your cash inflow and outflow doesn't happen at regular interval, you need to use another function called XNPV. The second thing is that NPV does not take into account the initial investment. That is, any cash outflow happens at time 0, and therefore we should be careful not to include in this example the initial purchase price of this investment. Having said that, the function itself is very straightforward to use. It just requires, first of all, a discount rate, which we specify in cell B3, 5%, and then the series of cash inflow. So in this example, it is from year 1 until the end of horizon where Thomas sells the apartment. And the last one is we can close this NPV calculation. The last step is to add back the initial purchase price, which we do here. And after we click enter, we have the results. So the net present value for this whole project is about $66,000.